Welcome to the UEI Technical Masterclass. I'm Bob Finn with UEI, and I hope everyone here is doing well on this beautiful summer day. Today, we're joined by our good friends at MDS Aero Support for a webinar entitled Measurement on an iDDS Bus. And the presenter will be Don Pereira. Don is a DAS product line manager at MDS Aero Support in Ottawa. And Don will be joined today by two of his MDS colleagues, Paul Suominen and Robert Schroeder, who are on hand to answer your questions about iDDS. So if you have any questions, send it our way using the webinar chat tool. I think that about covers the ground rules, so I'm going to hand this presentation over to Don.
All right, thank you very much for the introduction, Bob. All right, so as Bob was saying, I'm the DAS product line manager at MDS. So we're developing a new data acquisition system that's based on iDDS technology. I'm joined by Rob Schroeder, who is the chief software engineer at MDS, and Paul Suominen, who's our DAS software architect. So certainly, you know, as I'm going along, as Bob had already said, bring your questions using the chat window. Don't worry about interrupting me. I think I'd encourage, you know, sort of a two-way live back and forth. I think that way, hopefully, it would be a little bit more meaningful exchange and learning session for all of our participants. And then, you know, depending on the technical depth of your question, that's why Rob and Paul have joined me here, because certainly they're the right guys to field any of those technical questions. So don't be shy and jump up and send us a question. Okay, so this is the presentation outline that I'll be covering. So first of all, I'll talk about the problem, or what got us to where we are in terms of developing iDDS. So then we'll follow on with that. So why iDDS? And then on to that, the benefits around iDDS. So all of those things are obviously related to one another. We'll talk about the goals for an iDDS-based system. And some of the core technologies that are being employed and written into some of the standards that we're working with. And then finally, I'm going to introduce the iDDS Working Group. So MDS basically started up that working group about 4 years ago. You'll learn a little bit about the participants of that group, and certainly we're going to encourage the people that are interested in our discussion today. If you haven't already joined that group, certainly join that group. It's a grassroots organization, and it's about developing the standard and taking it forward. Excuse me, then I'll just give you a picture of what a typical iDDS-based data acquisition system architecture might look like. And then I'll introduce a software development kit that MDS is made available to people to accelerate their entry into this iDDS world, if you will. And then we'll just do a bit of a wrap up. Okay, so the current day industry protocol, there's a frustration around connecting data acquisition systems with instrumentation, and that primarily stems from the fact that hardware vendors have proprietary interface protocols, and they come to the market with those, and they make those available typically for people to connect up to their instruments and ultimately acquire data from them. So they may present drivers to the marketplace, but if the drivers are available, there's integration time associated with that. They're often unique, and they might offer a Windows driver but not a Linux driver, or vice versa. So they might not be supporting the operating system that people might be using, or they might not support a real-time operating system. So that's part of the problem. And then also, the drivers that they supply might not be suitable, which means that people that are interested in integrating that hardware might have to rewrite them from scratch. So that obviously becomes a costly exercise where you have to write the driver codes, you have to write test procedures around that, you have to test it, you have to integrate it. Ultimately, as in many software houses, you have to pass that over to your product verification group that are going to run test suites on that software to make sure everything's good before ultimately you're releasing it to your customer. So then the next thing is with respect to configuring that hardware. So there's options in terms of setting up instruments both before you go into scan mode, but then also in terms of if an instrument is scanning. So like an example might be, you know, if you got a pressure scanner, that device might have a purge command, for example, so you might be interrupting its normal data acquisition and publishing cycle to tell it to purge or something like that. So there's often controls that are required even while you're in live mode. And then the next issues associated with, you know, where the hardware is actually, you know, does it plug into, is it a rack mounted chassis? Can it be mounted close to the unit under test? And then there's also issues around backwards compatibility or obsolescence issues as data acquisition systems move forward or instrumentation moves forward. We have to account for all of those things. Okay, so then why iDDS? So first of all, what is iDDS? So iDDS is an instrumentation-centric version of DDS. DDS being based on OMG DDS, which is a data distribution service, which is a publish and subscribe way of exchanging data on a data bus. Okay, so the idea around the iDDS group is it's a group, as I mentioned already, of grassroots group, yeah, interested in developing a standard. And the main goals around that standard was, first of all, to deal with that problem that I already described. So it's about reducing new hardware integration and driver costs, okay? And the standard solves that interface challenge in an open format. So the document or the standard documents will be open. People can go get the documents, read them, and ultimately bring instruments onto the market that conform to that standards. The other goal is to reduce integration time. So as I already mentioned, we're using the object management group's DDS publisher subscriber framework as a basis. So that gives us a common interface definition language, and it's going to allow us to do two things. So it's going to allow us to control the instrument, both from a configuration standpoint initially, but then also from a live control if you need to change mode of the instrument while the data acquisition system is actually running. But then also, you know, the other very important bit, of course, is the ability to grab data from that instrument while it is scanning. And then finally, the other thing we need to also consider legacy support. So, you know, this is a new standard, but then we also have to be able to think about the control path interface, and can you set up a device to stream data in older type of formats? You know, so can you still use TCP/IP or other data formats in order to acquire data for older instruments that are on the same bus that are not conforming to the new standard? And then finally, one of the last main features around iDDS is it is using the IEEE 1588 standard by way of time-stamping data at source. So all of the compliant devices that are complying to the standard will be required to time-stamp their data, and then they're publishing EU converted or EU data, engineering unit data, along with a timestamp onto the bus. Okay, so I want to talk about the benefits. So I'm thinking about three unique groups here when I talk about benefits. So first of all, there's the user, or, you know, in our world, it's the people that are actually using the data acquisition system, the instruments to perform tests. There's also instrumentation hardware vendors, like our friends at UEI. And then finally, there's benefits to data acquisition system providers like MDS. Okay, so first of all, for the users. So the user is going to have the ability to add new iDDS hardware as it comes onto the market without changing software, because he'll buy a device that will be conform to a standard. He can plug that device into his system and run with it. It will publish data for him. And then also that allows him to scale his system up. So, you know, if he wants to add more pressure channels to his test facility, more temperature channels, whatever, he can buy those scanning devices, those measurement devices, and simply add those into his network. And then also he's not tied to, sorry about this, friends at UEI, he's not tied to a particular instrumentation vendor or a DAS supplier as far as that goes. You know, he can go onto the market with confidence as more and more vendors and DAS suppliers start offering hardware that conforms to the standards, and he can choose which instrumentation he wants, which DAS vendor he wants. And then it allows customers and third parties to write special custom applications. So iDDS describes a way of acquiring data. So if you think about, you know, in my world, primarily gas turbine engine that's running, you know, you need to acquire measured data, and you need to do some performance calculations, for example. The standard allows a person to write a custom application, for example, to go and grab measured data and do some standard day or other types of performance, aerodynamic or thermodynamic performance calculations on that data. So they can write their own applications. And we have a vision that somewhere down the road, if that application is of interest to other people in the marketplace, that they can publish that application for people to download, much like you download an app for your iPhone. So the idea that apps will be iDDS compatible apps would be available in the future for other people to use. Okay, so I see that I have a question from Christopher. His question is, how can I access the spec documents for iDDS? The iDDS website seems to be locked down and registration has been disabled. Okay, so great question. Thank you for that, Christopher. So to access the documents, you need to register with the iDDS Working Group. It's not restricted, and registration is free. So towards the end of the presentation, certainly I will share my email address with the whole team. And Paul Swamanen is currently acting, I think he's still acting, as the administrator for the website, so he can give you access and you can get a hold of the specifications there. Did I miss another question? Oh, yes, okay. So there's a question here. Do I have to use a third-party DDS vendor such as Twin Oaks, or does the UEI MDS box come with its own DDS? Paul, maybe can I pass that question over to you?
So the DDS or the cubes from UEI have the application that is already DDS compliant. UEI are using our SDK and then built an application for a wide variety of cards, and our SDK actually embeds there's several different commercial versions and open DDS as well. We've embedded Twin Oaks into our SDK. Yeah, so that hopefully that answers that question. There's no additional stacks required to use the UEI cubes and their acquisition cards to be able to get DDS data or iDDS data from those devices.
Okay, thanks, Paul. All right, so moving along. So the goals behind an iDDS-based system. So first of all, our goals in terms of being data acquisition system provider are that we're looking to have a model-driven hierarchical control-based schema that we will then use to configure and control the entire measurement network. So we want to, or we have devised a common model-driven interface for network-based data acquisition devices. And then we're using a standards-based approach. So we've leveraged some telecom network management system principles in our approach. So around the control interface, we're conforming to a standard that is known in the industry as FCAPS, which stands for Fault Configuration, Accounting, Performance, and Security. So it's a framework, or it's a foundation upon which we've built our data acquisition system that allows us to gain access to data associated with all of those areas in terms of doing health monitoring of the data acquisition system, configuring, but then also managing accounts as far as possibly using that information for billing, and then managing the performance and the security of the network as well. And then we have utilized centralized AAA. AAA stands for Authentication, Authorization, and Account Management. So it's just again, it's a telecom-based principle that allows us to manage all of the users that will want access to the data acquisition system network. Okay, so further goals. So ultimately, we're going to get to a plug-and-play world where, like plugging a USB stick into your computer, it recognizes your computer and you can get data from it, or a printer or whatever. We're going to get to that place with respect to plugging in a UEI cube, or plugging in a temperature scanner or a pressure scanner. And then on our side, it's going to be about self-configuring editors. So rather than every time you add a new device, you have to go in and write some code in order to have your configuration editor recognize those devices. We're using textual model-based data in order to have our configuration editors recognize a new device according to its model, and then allowing the editor to self-configure to be able to gain access to the configuration structure of that device. Then also for us, model-based validation and rollback is very important. So network-wide, if a user makes a change to the network, configures a device in a different way, puts it into some operating mode, and that ultimately results in undesirable results, that all of that will be tracked, validated, and then you could always roll back that change if you've made some kind of an error and caused your network to become unstable. So we're also going to be supporting transactions for a single commit. In other words, you can make many changes to the data acquisition system configuration in an edit session or a configuration session, and then have all of those transactions pushed out to the devices with a single commit of those changes. We'll track changes for configuration control. And then finally, I think that this is an important feature is with respect to error reporting and ease of troubleshooting. So we're using that state management function that I talked about earlier, and because that's built into our network architecture, we'll be able to determine the operational state of any device on the network, whether it is operationally enabled and healthy, whether it's operationally enabled and somehow degraded, maybe one channel out of 16 or out of 32 is not scanning, or whether you've completely lost control of that node, that scanner has gone down and it's unavailable to you. It appears in a red state. So from our instrumentation management system interface, we'll be able to identify the state of any device and ultimately give the user options to bring that device back online. Okay, some of the core technologies that we're using then. So around the control interface, we're going to leverage industry standards. So we're using Yang 1.1 as a data modeling language. So that's going to describe the hardware that's coming onto the network, ultimately how to configure and control it. And then ITU-CC ITT X731 with respect to state management. So it's that standard that's going to allow us to monitor health of devices on the network, as I just described earlier. IEEE 1588 PTP for timestamping at source. We touched on that already. And then, as I already said, OMG DDS by way of publishing and subscribing, and there are a number of commercial stacks available. And we've chosen Twin Oaks. It's well supported. They've helped us along as we are on a journey in terms of developing our data acquisition system. But you can also use OpenDDS. It's really up to the user to decide what they want to do there. And then the data interface. So our goal is a stable industry standard transport layer. So again, sharing data among the network devices based upon OMG DDS, but then also, as I mentioned already, that network needs to be able to support other data interfaces as well, such as TCP/IP and UDP and so on. So the iDDS Working Group. So I think I may have already mentioned it was about 3, maybe 4 years ago that MDS started up this iDDS Working Group. We've been reaching out to people within our network or organizations within our network. So we're a gas turbine engine test company primarily. So we're reaching out to people, inviting them to join the group. This is a list of some of the organizations that are at the table and helping us to develop the standard and to determine its growth path. So you'll see companies here that a lot of them are aircraft or Aero engine, big names like Rolls-Royce, like Pratt & Whitney. There's also airframers like Airbus, like Bombardier, and then of course instrumentation companies, of course, like UEI, like Bustech, like Shell, and then other data acquisition system suppliers like ourselves, like Yano Aerospace or Apex Turbines, or who else is on this list here? I know there's one other that I'm thinking about. Oh, ASC, of course, ASC Holdings. So those people are coming around the table. The meetings occur typically monthly, sometimes every 2 months, and we look at proposed changes to the standard and determine how we are going to evolve the standard to meet everyone's needs. Okay, so here is a high-level overview with respect to the DAS architecture. Okay, so the box over on the top left-hand side represents an instrumentation management system or a data acquisition system. So the data acquisition system, of course, is publishing and subscribing to data on the data bus. In the middle is the iDDS data bus. The goal of the working group is that we're going to be able to transmit data from low speed, let's say 0 hertz or 1 hertz, all the way up to dynamic data speeds of 256 kilohertz. So the instrumentation management system is going to serve a couple of functions. So first of all, it's responsible for configuring the data acquisition system. And we're doing that using these Yang data models in terms of that's what's telling us what the instruments are out there and how to configure, how to control them. But then the other important part here I mentioned already is with respect to managing those devices and understanding whether they're all operational and online and healthy, or whether maybe there's some kind of degradation or issue with respect to that. Okay, so then over in the bottom left-hand corner, this is the instrumentation nodes part of it. So each of these instrumentation nodes once they are configured, they're primarily publishing data, or certainly in scan mode, they're publishing engineering unit time-stamped data onto the network. And so each of them need to be connected to a PTP time source so that they have that synchronized clock to timestamp the data that they're making available onto the bus. Okay, the top right-hand side represents real-time display instrumentation nodes. So this is where users in your test facility are ultimately looking at live data to monitor the instruments, but I guess probably more importantly to monitor the devices or the systems being measured by those instruments. And then finally, over on the bottom right-hand corner, we need to be able to get data external to the test facility. So typically you have a test facility network where you have the data acquisition system and the measurement instruments, but more and more the demand is to be able to make that data available to an engineer who's sitting in an office and not sitting in the test facility. He needs that data in real time to perhaps help coordinate the test facility, the test as it's happening live, or maybe he's doing some performance calculations or something like that. So we're envisioning that through a gateway node, again, we're publishing data and making that available to remote data subscribers. Okay, I see I have another question from Christian. So the question is iDDS able to manage avionics buses like Airing 429 or MIL 1553? Rob, can I pass that question over to you?
Sure. Right now, we haven't really addressed Airing 429 or MIL 1553. Those are things that we're starting to talk about now in the work group about how to best handle the data coming from an Airing interface or MIL 1553 and even AFDX. So for the avionics buses, it's something we're now starting to talk about and planning to address in the work group. So we're hoping to have something towards the end of this year to handle or address those avionics buses.
Thanks, Rob. Yeah, that's a great question, Christian. Certainly, we and probably a lot of people in the training session recognize the increasing importance of those avionic buses, because most of the data that's coming off of a FADEC or an EEC controlled device or a computer controlled device is via those avionic buses. So as Rob said, that is an active subject for discussion around the iDDS table right now. So thank you for that. All right, so I'm just going to briefly touch on MDS's iDDS software development kit. So we have a software development kit. It's basically allows for rapid integration of iDDS into devices. So when we're talking to people in the industry, certainly some people have experience with DDS, and so the transition, I guess, to the iDDS standard is not as painful for them. But if instrumentation or other people out there don't have experience with DDS, then to jump in and read the iDDS standards and bring compatible devices onto the marketplace is a bit of a daunting task. So we do have an SDK that can speed up that process. So we use it to develop, test, and validate the application protocol, and certainly instrumentation or other people can use it for the same purpose. So the iDDS application protocol shall not be an open standard. So, shall be an open standard, excuse me. So it is an open standard, and you can ultimately read it and conform to it. So the application protocol is lightweight, and it doesn't require a DDS stack with large features. So it enables people to use the SDK if they're interested in it, and it doesn't require a lot of horsepower, doesn't require a lot of memory on the devices. Anything else you want to add to that, Rob or Paul?
No, I think that's good.
Okay, thank you. Okay.
Only that many of these devices are x86 on the standard, on host computers or 32-bit versions. We have vendors also that have either ARM, V7, and or PowerPC platforms, and we've provided the SDK on those as well. We can introduce other targets as well on demand if required in the future.
Okay, thanks, Paul. Okay, so just to wrap up then, so we believe that iDDS is the future of measurement systems because the broad-based goals around reducing new hardware, integration, and driver costs, I think, benefit the entire community. It solves a common interface challenge in an open format. It reduces integration time, so we're using OMG DDS for the data acquisition system control and the data path interfaces. There's a lot of interest in the measurement community around when was that value actually measured. So certainly time stamping at source to IEEE 1588 is in high demand, at least the people that we're talking to. So it does address that issue as well. So if you have follow-up questions, or if you would like to join the iDDS Working Group, that's my email address. So it's don.pereira@mdsaero.com. So certainly reach out to me with questions or whatever, and I'd be happy to answer those. Okay, over to you, Bob.
Okay, thanks, Don. I think that concludes today's presentation, and I just wanted to thank you again, Don, Paul, and Robert, for your excellent presentation. A few things to note: our next UEI Masterclass will be July 23rd, and the topic of this particular webinar will focus on accelerating product development using UEI's automotive solution. We record every webinar and post the videos online, so you can watch any of our previous sessions. And we now have 12 of them, 13 if you include this one. You can either watch them on our YouTube page or on the video page on ueidaq.com/videos. And finally, if you've got any questions, you need additional support, or you've got suggestions for future webinar topics, please email us at support@ueidaq.com or give us a call, 508-921-4600. We hope you found today's webinar useful, and we will see you again in 2 weeks. Once again, thank you everyone for joining us, and as always, please stay healthy.